Okay, so today we're going to talk about scientific measurement. So you've been measuring things since you were in elementary school. But in chemistry, we want to make sure we're taking the absolute best measurement that we possibly can on there. So we'll be measuring lots of different things. You can see here an example of a glassware. You probably know that that's called beaker. We'll use things like meter sticks or rulers, find things like volume or area. So all of these start with getting the best measurement we can. Okay, so a measurement is a quantity that has both a number and unit on here. So it's really important. If I just write down 5, I don't know if you're talking about 5 grams or 5 milliliters or the densities, 5 different things on there. So you want to be really specific because there's a big difference between having 5 grams of something or 5 kilograms or 5 milligrams for it. So what we want to include, all known numbers, plus 1 estimated spot. Now in science, we always want to use decimals, not fractions. And again, we want to use the metric unit. So pretty much every single time we're doing something in here, we're going to be using the centimeter side of the ruler. If you were here, sometimes we might have you measure in inches and convert to centimeters and that just to practice like that. But science, we all have certain things that we like to use, so which is going to be the metric system. So things like centimeters, meters, grams, kilograms, different things like that. Okay, so here's some examples of some of these units you might see. So you don't have to know every single one of these, but the most important thing is to kind of understand if something's a big or a small number in there. So in the middle, we have our base unit. So the metric system, or SI, System International, uses these units on there, and then we add the prefixes. So you probably used these before. You might have learned something like kids have dropped over dead, converting metrics, little things to help remember, moving the decimal. We're going to learn later a way to convert these and move these different ways where we're going to use what we call dimensional analysis or factor label. Some of you might have seen some of that in middle school, which will be a great start if you've seen that, but if not, we'll teach it and go through each of these things. So on this here, our big units here are over here. So mega, on there you might have heard something like megawatts on there. There's some different ones there between there, but the main ones we use then would be kilo on there. Hecto, deca, then the base units would just be like a gram or a liter. So then these get smaller, deci, centi, milli, micro, and then the smaller one in here. So you've heard of like nanotechnology on there. Things that are really small might be like a micrometer, things like that. We're talking about stuff like how wide a hair is and tiny little things like that, where a lot of these machines and factories have to be super close on things, and they've only got so much leeway on where they can go. So again, every time you move on this line, it's a factor of 10. So deca and hecto right here are just one space apart. So that would be a 10 times of difference, or milli on here, on deci on there. So if you move 2 spots, for example, that would be 100, or 3 would be 1,000 on there. So for example, milliliters to liters, you'd be moving 1, 2, 3. And so that would be 1,000 on there. So again, those dots in there just represent that there's other measurements in there, but we just focus on these like to the -3rd, the -6, kind of the more useful amounts from here. Okay, so again, we'll be using dimensional analysis conversions later, but here are the ones that I want you to know that you should really not even have to think about at this point because you've seen them so much on here. So milli means 1/1000th. So a millimeter is 1/1000th of a millimeter. So if you look at your meter stick, the smallest marks in there are millimeter. And if you were really bored and you counted every single one of those, there would be 1,000 on that stick. Centi is 1/100th. So if you look at a meter stick, it's got the big numbers up into 100 on there, which would be the end of the stick. So 100 centimeters make up the meter. Kilo is the opposite on there. It's a bigger unit, so it is 1,000. So if I wanted to have a kilometer on there, which if you run is similar in length to miles, it's a little bit shorter. But I would have to put 1,000 meter sticks in a row to get that kilometer distance. Okay, so bigger things like really heavy objects or really long races are going to have kilo. Really tiny things are going to have things like million centi, or they could even go to one of those other units I showed you later. Okay, so the important thing we need to be able to do here is be able to read things correctly based on the tools we have. Now look at these rulers A, B, and C. Which one of these do you think would be the best ruler to measure with? Hopefully you said ruler C would be your best one here because it has the more marks, and the more marks you have, the less you're estimating on here. So if people are giving me measurements on there and they're not getting very, very close to each other, they probably don't have a great measuring tool. Normally we do a lab and we would test some different measuring units in there, some different pieces of glassware, and we'd realize that our favorite piece of glassware is going to be the graduated cylinder because like ruler C, it's got a lot of marks on here. Okay, so we're going to practice doing what I said. You're going to include what you know for sure, and then you're going to estimate one more spot. So these are all the same object, so the measurements should be close to each other, but we need to estimate on here based on what we have. So let's look at ruler A. There's 0 and 10. So what you can kind of do here is figure out on here about what you think the middle of our ruler is on here. So probably somewhere around here. Again, I'm just eyeballing this on here. Then I would say this is less than 5, so I know that for sure. However, I don't have any more measurements than this on here. So if your device goes by tens, I want you to read to the nearest whole number on here. So that means in something like this, I'd want you to just tell me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever one you think is closest to this. All right, so if I look on this, I kind of eyeball, think about where 5 would be on that. It's closer to 5 than 0. So I would write my measurement here as 3 centimeters. Now if something does have a label on there, it is a good write on here. Now I don't want to say 3.0 on here or any extra numbers on there because I want people to know on here that I'm just approximating. It's about 3. So if I asked you, say I bought a snack and I said it's about $3 on there, I'm telling you to the nearest dollar. I didn't tell you it was $2.85, or I didn't tell you it was $3.11 on there, some other number in there. I'm saying it's about $3 kind of thing. So same thing on a measurement. You just want to tell what you know. All right, so in ruler B, we see more markings on here, and our metric system loves the number 10. So we can tell in here that these are our numbers 1 through 10. So 1, 2, 3. So this is pretty close to 3 on here, but it's a little bit over 3 on here. So again, if we were estimating in here and said about halfway roughly, my numbers, beautiful handwriting on here is a little off on here. It's definitely not closer to 4, it's closer to 3. It's definitely not close to halfway on here. So in this, I would probably say 3.2 centimeters. Now, if you thought it was a little bit higher or a little bit lower than me, your answer would be acceptable because anything we're doing with the human eye, we're estimating on there. So unless something is totally blatantly obvious on something on there, there is going to be a little bit room on there that I would take an answer a little bit higher or lower. However, that doesn't mean I would take more numbers or less numbers than are on there. I want to write down the correct amount based on what I see on here. Okay, so our last ruler on here, now we can see it's by the 3.2. It is very close to the 3.2, but it looks like it's a little bit tiny over on here. So I'm going to say 3.21 centimeters. Now again, these are pretty tiny on here, so it's a little harder when the marks are super close on there. I don't want to just say 3.2 though, because if people see that, they're going to think I estimated like I did in the past one on there, but I'm positive that this is by 3.2, and it's very close to the line on here. I don't want to add any more numbers, no fractions, no decimals or quarters or anything like that. I just want to include everything I know. So in here, what we know for sure on this, on the estimated and the certain digits on here. On the first one on here, we had no digits that we were absolutely certain of on there. We just knew it was between 0 and 10. On the next one, we were positive about the 3. And then on the next one, we were positive about the 3 and 2. So I'm going to mark those digits I was certain of with the green. Now my estimated ones, on here I estimated the 3 was between the 0 and the 10. On this one I estimated that it was a little over 3, so 3.2. And then 3.21 in here. So notice in each of these I wrote down the numbers I knew for sure, and then I just estimated one more spot. Okay, so here's a couple of examples with some beakers on here. Now, on a liquid, you may have what's called the meniscus on here. So if sometimes liquids are really flat, things like rubbing alcohol and things like that are like that. But a lot of substances are going to make this little curve down here. And hopefully you remember where we read that. And this is called the bottom of the meniscus. And that's where you want to read. So if it's not really level on there and you see this curve like we're going to see in this next picture, we're going to estimate it a little bit more. So go ahead and try and read these. Okay, so in this next one on here, I can see this 80 mark, and I can see that this is just below this. So this is just a little bit less than 80. So in here, I would call this 79. And then on this is milliliters, because that's labeled. So again, if I was recording this in a lab, I'd want to make sure to add that milliliters, because there's a big difference between 79 milliliters and 79 liters. A small beaker versus, like almost 42 liters of soda kind of thing was a big difference on here. All right, now if somebody thought that was exactly on the 80, 80 could be a correct answer in here. I'll show you this on the next page on there. So it's pretty close to 80, so I would be okay if you're one higher. 78, that probably could be okay, but we don't want to see anything smaller than that. Okay, so that was by 10, so let's look at our next one. So I see this is close to 20, it's between 20 and 25. But on here, I see every mark on here is ones. So what I'm positive here is this is between 21 and 22. And on here, I'm going to look at the bottom of the meniscus here. So I'm going to kind of level off where I see this little bottom mark is on here. I'm looking at right there. Sorry, it's kind of hard to draw with this sometimes. And I would say in that's right about halfway, maybe a little bit higher in here. So in this, I would get an extra number because I know it's 21 point something. And so I'd write 21.5 milliliters, or maybe I thought it was 21.6. But again, if my answer is not between 21 and 22, I know I didn't do a good job recording. I wouldn't want to record just 21 because that wouldn't give me enough information for doing things later. Okay, so if it's on the line on something like this, so say for example, I'm measuring something and it's exactly on the 3 here. We don't want to just say 3 because people are going to think that's estimated then. So if it's exactly on the line on there, it's exactly 3. So exactly 3 would be 3.0 on here. So anything that's right on the line is going to have a 0 on it. We're going to talk a little bit later about something called significant figures or sig figs, or some people call them significant digits on there. You have to be careful with zeros and make sure you're letting people know if it's a measuring number or not. So I talked about that graduated cylinder a second ago. If I wanted to tell people I thought it was exactly on the 80 line and it went by tens, I would write down 80, but I would tell people that that 0 is actually my estimated number in that, the one I know for sure that it is significant, by either put in the bar there. I could also write 80 and put a little dot here on that, meaning, hey, this was actually measured. You don't want to put an 80.0 because that's telling people that every number is marked. So even though 80 might be marked on there, we've got to put let people know that not every little number is going on there. So again, showing on the lines means there's a 0 on there somewhere. So it's really important in our lab measurements when we hopefully get back in the lab that you include zeros. So like if your balance the scale says 2.00 grams, that's just as important as 1.95 grams. All right, so going along with this, there's some numbers, accuracy, precision, and error that we might ask you to look at your data. So accuracy indicates how close a measurement is to the true value. So when we buy something like a balance, it comes with a standard on here. So this would be a 100-gram standard. And if my balance is working well and giving me good readings, it should read 100.00, just like this one. So on this one, the one on the right in there, it's inaccurate on there because it's not giving us the right answer on there. So if something's off, like if our scale's reading a little bit low, or if our ruler, it wasn't calibrated very well, you're not going to get the best possible answer on it. Okay, so accuracy means you're close to the true value, that you're getting the number, it's right. It's supposed to be what it's supposed to be. We also know on here that with accuracy and precision is another word on here. So precision on here is how close together or how repeatable the results are on this one. So precise measuring instrument will give very close values, close together values, every time it's used. Okay, so let's look in this dartboard on here. The person who threw the darts did not do a very good job of hitting the bullseye, but notice every time they're getting answers that are close together. So we would call that is precise on there. They're doing things the same way. They're getting things very close to where they should be, or to each other, I should say. All right, so accurate, again, means that it is correct, and precise just means that it's close together on there, that you're getting similar values each time on there. All right, so what this is going to build up to, which is the next thing we're going to do, is what we said is called significant figures. And significant figures on that, just like you're reading the number on this, should tell us what we're looking for on here. And so again, it's how accurate it is, the accuracy of the measurement. And just like we were doing when we're looking at things, we're going to include the known digits, which just means the lines, the stuff we know for sure, plus a final estimated digit. Okay, so using what we were doing before, I want you to look at this paper clip and come up with the value for this. So on here, look and see what you know. And what we know on here is this 2. We also know right here that this is on the 3rd line. And it's very close to that line, but it looks just the tiniest little bit over here. So the way I'm going to do this is I'm going to write 2.31 centimeters. So when I was talking about the significant figures on here, I would include my 2, my 3, and then my estimated digit, which is my 1. So if I asked you how many significant figures are in this number, you would say all 3. Now, where this is going to get different is with some very big and very small numbers and things where you don't have the best measuring tools and whatnot, and we'll work on that, and then we'll start doing some calculations with that too. All right, that's it for today. So again, with these, you can follow along, you can take your own notes, you can print these out, whatever works best for you. And that I'm not going to be collecting your notes, but you will be having some Canvas assignments that you're going to have to do based on what you saw in this. And when I give these to you as homework, you're going to be expected to do some of the things the next day. So make sure you're watching these. Thank you. Bye.